Okay, everybody, we'll be going live here in just a second. Just trying to connect it to LinkedIn. We'll wait just a second here for some other people to roll in. Okie doke. And just a heads up, we got some team members that'll be monitoring the comments on the different social platforms and here in StreamYard. So feel free to ask any questions. They'll try to answer them if they can. And if it makes sense to work into the webinar, I'll answer those live. We'll get started here in just one more minute. Good evenings. Oh my gosh. Sorry. It's so late over there. It's very much early here. Okie doke. Okay, so as mentioned earlier, some of my teammates will be monitoring the chats for any questions. Feel free to ask them as we're going along. We're also going to do some Q&A at the end, just about Terraform, infrastructure as code, any questions that are outstanding. But anyhow, welcome. Thanks for joining us. My name is Corey. I'll be your host. I'm the CEO and co-founder of MassDriver. MassDriver is a visual development environment that helps teams deploy production-ready infrastructure in a matter of minutes. I'm also the maintainer of the Elixir Kubernetes library and a framework called Bonnie that lets you extend Kubernetes with Elixir. I've been in the IAC space for about 15 years. I've written and deployed hundreds of Terraform modules, including some 5,000 plus node Kubernetes clusters. So I've been in the space. I've seen some pretty wild stuff. But I think what I want to start with is just talking about like what really is maintenance when it comes to infrastructure as code. And it's not just the code itself. It is also how you organize the code, how you organize your modules between your different infrastructure environments, and how well your infrastructure is organized after provisioning. Also, it's about codifying conventions of your business, the non-negotiables of your security and compliance, and reducing the cognitive load of the developers on your team that are using the modules. So let me go ahead and get started. So first, for anybody who's not familiar with infrastructure as code or hasn't started using it yet, what is infrastructure as code? It's managing and provisioning your infrastructure through code in a declarative manner. What you want to focus on is what you want in the cloud, not how to get it. It's not a lot of conditional logic saying, if there's a cluster, add some additional nodes. You simply say, I have a cluster with nodes. And the tool takes care of making sure that that state in the code is reflected in the cloud. And IAC is integral to the modern cloud ecosystem. It enables fast, consistent, scalable infrastructure management. To be able to manage infrastructure at a massive scale, it's a real key tool. And when we look at some of the alternatives here in a minute, you'll see why it's really important to adopt. But at the end of the day, one thing that's important to think about when you're using infrastructure as code is it's not actually code. It's infrastructure as configuration, right? What you see with Terraform and even Pulumi and Ansible and all these other tools is their cloud configuration. At the end of the day, it's just fancy JSON objects that are getting applied to some cloud's API. There's a sprinkle of logic on there, but for the most part, what you're looking at is configuration. You're not looking at business logic. And that's really important as we kind of dig into like when to take a dependency when using modules and infrastructure as code, which we'll dig into here in just a minute. So what are the tools in the space? So there's Pulumi, there's OpenTofu, which is a recent fork of Terraform that MassDriver is a sponsor of. There's Terraform itself. There's AWS CloudFormation, which just works for AWS. There's Crossplane, which is a Kubernetes-based IAC tool. There's Puppet, there's Chef, there's SaltStack. There's a lot. IAC tools are a dime a dozen, and this is one of the problems. When you start working with IAC tools, it's very common to hear somebody say, Terraform is hard. Terraform's not hard. Terraform's an extremely simple, very basic language, but it's easy to conflate Terraform being hard with the cloud is hard, right? And so the first time you're working with Kubernetes, it can be confusing on how to set it up, but a lot of people kind of attribute that to the tool that they're using rather than the service that they're trying to learn. And I think this is one of the reasons that we have this sprawl in tooling. People try to go and solve this problem again and again and again, where the heart of the problem really is the gap in knowledge between the average developer and all these services that the cloud offers. So this talk will focus around Terraform and OpenTofu, but the concepts apply to any of the declarative tools in the space. And there's this other tool called Warning Shot. This is a throwback to how long I've been doing this. So this is an IAC tool that I wrote about 15 years ago in Ruby that's very similar to Ansible. It's not great. None of them are. So, okay, cool. So let's go ahead and get into some of the benefits of IAC. So the one that you'll hear people kind of praise the most is consistency and automation. It helps you avoid manual errors in configuration by being able to have like this pull request flow, seeing the stuff in code, and being able to apply it multiple times to different environments. But scale and efficiency is another one. If you think about an e-commerce company, we have bursty traffic all day long as people are coming in for sales or something is becoming hot. But there's one time of year where we know there's going to be a lot of sales, and that's Black Friday. And so the ability for a company to massively scale up their infrastructure quickly in response to spikes in traffic that might be outside of their normal auto-scaling bounds. And that's one of the really interesting, powerful things that IAC can do is let you kind of spin that stuff up quickly, spin it down quickly whenever you have these major spikes. And I think the most important thing that you get from this is collaboration and version control. It's really hard to collaborate clicking around in the AWS console, right? It's very hard to collaborate by running some stuff on a CLI, right? And so to be able to simply say, like, here is how I want my Kubernetes cluster to look in production is very easy for us to look at over a pull request and comment on. Now, the alternatives, there's two. There are two alternatives to doing infrastructure as code. Now, be curious, if you're not doing infrastructure as code today, which one of these you're doing. There's ClickOps, which is manually clicking around in AWS console. It's time consuming. There's no version control. It's very inefficient if you're making lots of changes. And then there's scripting. And scripting is a fine one. But what you see with scripting is it gets very hard very quickly. If we have to check the API for EKS to see if there's a cluster, and then if there's a cluster, apply a configuration. If there's not a cluster, create the cluster, right? We get kind of in this imperative model that creates a lot of boilerplate code. When at the end of the day, we just want to say, we have a Kubernetes cluster and it's running 13 nodes or whatever. What do we got in the comments here? Okay, sorry, I was just seeing if anybody, what's everybody doing today? Is everybody using IAC today? Are you doing a lot of ClickOps, a lot of scripting? Are you 100% IAC, just starting to dabble in it? You just share in the comments. Quiet room, okay. Let's keep going then. So looking at adoption of IAC, this is actually very concerning to me. The State of CD report, State of Continuous Delivery report, found that only 27% of organizations are using IAC. It's 19,000 organizations surveyed. So just barely over 1 in 4. And IAC is very key to a lot of the other things that we want in engineering. We want good DevOps practices. DevOps is hard. I have opinions on DevOps, but it's really hard to get to good DevOps without infrastructure as code. It's hard to get to good platform engineering without good DevOps. And it's hard to really put all this infrastructure as code and control into the average developer's hands without all three of these. And so I kind of see it as building blocks, and IAC and managing your infrastructure well is kind of the base there. If you guys to chat about IAC styles, we're seeing a lot of Terraform, AWS CDK, nice, very cool. I really like AWS CDK. It is very, very cool. Terraform CDK is pretty cool too if you need to do multi-cloud stuff. It's a great tool though. So this is concerning me. I would love to see more people adopting IAC, but this is the state of the world. And the thing that's really sad is the 2002 survey had about 19,000 respondents as well, and it was also 27%. So IAC growth has kind of stagnated over the last 2 years. So what are the challenges in writing good IAC? Well, there are two hard things in infrastructure as code. I'm going to tell you the first one. I want everybody to guess the second one. So the first one is understanding the underlying service, which isn't an ISE problem, right? Again, like Terraform and Pulumi and these different tools have very limited amounts of syntax. They're very basic languages. So the harder part is understanding and having that deep knowledge of the service, its auxiliary services like IAM and KMS that you need to put together. So that's really one of the big hard parts. Does anybody know what the other hard part is? I'll give you a hint. It's the same hard part as everything else in computer science. Okay, the other one is, whoops, I skipped too far ahead. The other one is naming things. Just like everything else in computer science, it is hard to name the thing. And this is what I think is one of the most important things when writing Terraform is thinking about the name. You have to really get an idea of what the use case is for the module that you're developing. And you want to build modules that are for specific use cases, not generalized. And we'll get into a couple of examples here, but what you don't want is a module for S3 buckets. You want a module for S3 logging buckets. And what this does is it creates a smaller interface, which increases the maintainability of it. If I'm thinking of a bucket as something that's going to be used for logging purposes versus maybe uploading or receiving like FTP uploads or doing ETL, what happens is I have a lot of context now. This is going to be for logging. I might have lifecycle rules of when this is going into cold storage. And I can codify all that in the module and not expose it to my developers and give them a very limited interface. It gives you clearer code. It allows you to start building in the expertise that your team has. It lets you build in the policies of your business and lower the cognitive overhead of anybody else using it. Things like database encryption. We all agree that databases should be encrypted. SOC 2 definitely wants you to do it. So why do you expose a field to your developers to let them turn encryption on and off, right? This should be a non-negotiable of your team if that's one of your policies and codified in these bundles so people don't have to, or modules so people don't have to think about it. So a couple of examples here. An S3 bucket. So let's say I have a module just called S3 bucket. What can you tell me about this S3 bucket? Nothing. How many people know how many attributes there are for configuring an S3 bucket? Does anybody know offhand? Don't look, don't Google it. Does anybody know offhand how many attributes there are? There are 98. There are 98 configuration options for an S3 bucket. Now, what can you tell me about this bucket? It's a logging bucket. It's going to have my company's lifecycles. I don't need to expose those variables to my engineers. I can let them focus on what they need to customize in a logging bucket. I can hide a lot of the complexity, give them just a few fields. Great one. This one's extremely use case specific. It's an S3 bucket for my ETL pipelines, specifically for raw stage, for receiving FTP uploads or receiving uploads from customers or receiving data files. It's very, very specific to a very specific use case. And now I can codify all of my expertise of what our raw stage buckets look like. Do they accept FTP uploads? Do they automatically delete files after some period of time? And nobody on my team that needs to make this bucket ever has to think about most of those rules. They can think of 3 to 5 to maybe 10 variables that they have to configure and set on my Terraform instead of 98. Another really good example is RDS. So making a Terraform module called AWS RDS. Well, AWS RDS has 2 different services in it. It has RDS and Aurora. They're very, very different. And inside of each one of those, there's a number of database engines, which are extremely different. Is it MySQL? Is it Postgres? Is it Oracle? Is it MariaDB? Is it SQL Server? Right? And so making a module for RDS takes a lot of overhead and thought if it's going to support all the things in RDS. But doing one specifically for Aurora, now you've taken out a lot of the instance scaling configuration that you see in RDS, and you're simply focusing on the configuration of Aurora. But going further and saying, well, we only use Postgres. Why even expose fields that are only applicable to MySQL or Oracle on this module if we're only going to support Postgres? And so internally having a module for AWS Aurora Postgres, I can codify a lot of the things. My team's expertise, our non-negotiables about how we run Postgres are codified into the module. And I expose just a few variables to my team where they can fine tune what they need. Things like version, maybe TLS certificates for doing secure connections, etc. So what's in a name? If you think naming a use case is hard, wait until your users start naming their cloud resources. If you look at the AWS official VPC module, or official one, the one that everybody uses, there's 8 name fields. There's 8 name fields. So if I want to deploy a network, there's a bunch of different options I have to configure, but I have to think of 8 different names. You should have a single name variable for your modules. And what you should do, yes, you should have one name field. So if I have a Postgres module, I have one name field. I don't have a name for replicas. I don't have a name for my primary. I don't have a name for my roles. I have a naming convention. And with that naming convention, that gives you the ability to give the user of your modules a very, very simple name field to put in. Tell me what the purpose is of this, let's say, Elastic Cache bundle. You're going to use it for page caching. And we have our naming convention codified into the module, so you don't have to think about it. If you, and what you see on the left here, this is our actual naming convention for MassDriver. This is how we've devised it. So we have a project, an environment, the module instance, effectively the name that the person's going to give us, a suffix that we randomly generate for every single provision, and then an optional suffix that the author can add on to clarify some things. So if I was exposing a single field for my users called name, they might put page cache. That's the purpose of this Redis instance they're using. And what would happen is I would dynamically generate all of these names for all the different resources inside my infrastructure component. I'd have ecom prod page cache 1, 2, 3, 4 for the cluster. I have the exact same name for the key. It becomes very easy now for me to go through the AWS console or listing out resources to tell what's related because they have the same exact naming convention. And then you can see here the bundle or the module author has added some suffixes for all the different replicas that are going to get dynamically spun up. It's saying replica 1, replica 2, replica 3, because there could be multiple instances of those. So naming conventions, I think, are really important to lowering a lot of the cognitive overhead of what you're exposing to your development team that's going to be using these modules. And what I would even suggest is if you're going to invest in doing naming conventions, make a module that does your naming conventions so you're not copying and pasting the code around. Let your customers or let your users essentially put in one name field and you generate the rest of it for them. Okay. Some other things. Don't put the region in the name on naming conventions. These are a couple of my opinions. Don't put the region in the name. You know what region it's in the UI and the CLI. Don't waste the space. You don't have a ton of characters. And when you're working on naming conventions, character count matters. Don't put the resource type in the name. You know what it is. It's in the ARN. You know, you're going to see that it's an RDS database or an RDS replica in the ARN. And don't put the cloud service in the name. These are a lot of things you see people put into the names, and it's really repetitive. Like, you know what they are from the ARN, you know what they are from the API call. So these are 3 things that I try to avoid personally. Yep. So I mentioned in the agenda that I might talk about the problem with registry modules, and I am going to pick on a few of them. And I'm not trying to pick on anyone in particular or any author in particular, but I'm trying to pick on this concept. And so when you look at the modules in the Terraform registry or any of the registries, what you'll see is they're very generalized. Module registries have abstraction bloat. They're low value code with a high cognitive load. This right here is a part of the configuration from the AWS VPC module. What you're seeing is their module is just re-implementing the resource provider's API below it, right? So now I have the cloud to understand. I've got Terraform to understand. I've got this Terraform resource I need to understand. And then I've got this module on top of it that I also need to understand, which isn't adding a ton of value. You can see it's just mapping the variables from my module into the resource. This is very common in the Terraform registry modules. And so you're accepting this dependency, you're accepting this abstraction, you're accepting these potential breaking changes and this black box around your infrastructure for no value on the other side. There's no expertise built into this. When you look at the VPC resource in Terraform, there's 27 fields. When you look at the AWS VPC module, there's 220 fields. Can anybody name 220 things about a network? I can't, right? And so that is one of the things that's like makes it very hard to use, right? It's like as soon as you see it, there's 220 configuration things you're immediately presented with, and then it has 190 outputs. It completely spills its guts to the world. And we'll get to the nightmare of outputs later, but one of the other things you see with this is there's 113 contributors to this one module. And again, you don't see a lot of logic in the module. It's a lot of mapping of variables. 113 contributors. This isn't Kubernetes. It's not Vault. It's not Terraform itself. It's a single module. And what's important about this is, again, it's not code. It's fancy configuration. So we have 113 people, 113 organizations, opinions on how to generalize a configuration. But nobody's putting logic on the expertise or how to run a network well. And I think that's why it's really important to own and write your own modules. You can use the modules in the registry for references. What resources should I use? But I don't think most of the modules in the registry are worth the overhead of taking on. One of the other things I think is really important in developing good infrastructure as code is absolutely leaning into locals. So if you're not familiar with locals, this is something in Terraform. There's equivalents in some of the other IAC tools. They're effectively private variables inside of your configuration. I always start with locals. I have no variables whatsoever when I first start working on Terraform modules. I like to work through my use case, get an idea of what I'm building, and then figure out what's important to expose to my users or customers for configuring this module. If I give them a smaller interface, I can always extend it. I can always add to it, but it's very hard to take fields away from variables in Terraform without breaking configurations. So I always start with locals, expand from there. The other thing that locals allow you to do is encode expertise. So locals aren't just a variable. Locals can be the result of different function expressions in Terraform. So you can do mapping, reducing, filtering. And so you can start to codify a lot of your expertise into these locals. And we'll see those here in just a second. But to kind of showboat a little bit, this is our VPC module that is in our official marketplace for Massdriver. There's 5 fields. It's not 27 that you see on a VPC. It's not 220 that you see on the AWS VPC Terraform module in the registry. It's 5. These 5 inputs, one of them will scan all of your networks in the cloud and pick a CIDR range that doesn't conflict with any of your other VPCs. This allows you to peer 2 years down the line when you need to, right? It handles all the internal, public, private subnetting for you. It takes care of leaving extra IP space for expansion. Takes care of NIST, CIS, SOC 2, and HIPAA compliant configs, right? Like this is the real power of locals. We can code all of that into the module and give a very small surface to our users to configure. And if they need something else, we can always add another field. We can always back out those local configurations to variables, right? They'll effectively become the defaults. And so this is one of our missions at Massdriver, is to help teams scale their operations. And this is one of the keys to doing it. Give developers really great defaults. Let them fork or open PRs to add additional functionality as they need it. But I think you always have to be serving that use case, right? Like not taking variables that don't make sense for the use case. You can always fork it and maintain it yourself if it doesn't align with the use case of that module. So here are the internals of that AWS VPC module that we have. And there's a link down here at the bottom. Can everybody see this okay, or should I open up the actual code? Kind of small, it's a little small. Okay, let me see if I can open this and blow this up a little bit. Okay, so this is just a real quick example here, but this is some of the stuff that we like to code into our locals, right? And so we're doing masking for our subnets. We're doing calculations on the sizes of the CIDR ranges. We're picking the NAT CIDR blocks based on high availability, right? We're able to codify a lot of that stuff in there and not expose these fields to the users, right? They get high availability by just checking a box. They don't have to think about the different AZs that are involved. That's all figured out and calculated behind the scenes. Okay, so let's look at the next example here. And so this one is from our AWS Aurora Postgres bundle. So what you'll see is we hard-coded some locals for easy referencing. You can see the protocol for import for Postgres. Maybe we want to extend the ability for people to change the port later, right? We can just go in here, expose this as a variable, good to go. But for now, it's just hard-coded, right? Why expose it if people aren't asking for it? But you can see a lot of the other stuff that we're doing in here is drawing up concepts. is this a serverless instance, right? Is auto scaling enabled, right? We're trying to document how our replica placement works down at the bottom, right? And so we're putting a lot of our expertise into this and exposing very few fields. And I think, again, like I know that's kind of been the mantra so far from slide to slide, but this is the real power of locals, and this is the real power of modules, is getting that expertise inside the module and giving a very small interface to your users, which makes your maintenance much easier. You can see down here at the bottom our total instances. We say that the total instances is always number equal to the replicas plus 1, right? So gives us the primary, gives us replica. The really interesting thing, the way that we apply this is, if we have a primary failure and it fails over to a replica, we don't have weird names like our primary being called replica, right? So we actually use these in the same configuration, the same naming convention, and allows us to have failover without having weird names of instances or kind of pet servers that are there that we know by name. Okie doke. And then we'll do one more here on leveraging locals. This is in our one of our SQS bundles, and this is probably one of the most use case specific bundles that we have. This is a really great example of a fine use case. So this is an AWS SQS queue that's specifically for pub sub with SNS, right? And so it's not a queue and here's 400 fields you have to figure out. This one is for connecting to an SNS topic and pulling off of it. It's always dequeuing. We don't make you think about marking something as FIFO and also getting the name right? That's something that's kind of annoying with SQS. You have to say it's a FIFO and then you have to end it with FIFO. You just mark the FIFO box and we'll set the naming convention for you based off of that. We also say that we should always have a dead letter queue. We don't want queues that can poison pill themselves. So there's no option to turn it off. It's just there by default, and we figure out the naming convention for you based off of our naming convention, and it's there. You can see at the bottom, it's dynamically figuring out whether or not it needs a KMS key. Wait, why do we optionally want to have encryption? That's not what this is for. Cross-region traffic in AWS requires KMS keys. For one service to be able to communicate with a service in another region, you have to actually be able to decrypt and re-encrypt between the AWS services, right? This is something that's really important if you have a queue that crosses regions. Your developers shouldn't have to worry about that. Right, making them think about, wait, is the queue in East and the topic is in West? Do I need a KMS key? Just being able to codify that in and let them just think of, hey, I need a FIFO queue. I need a FIFO queue with this much throughput, right? And not making them think of some of these other things that aren't negotiable. They shouldn't be able to have a KMS key or not in a multi-region environment. It's required. So one of the other key things in writing maintainable code is getting parity and life cycles right. And again, maintaining the IAC isn't just about the code, it's about the infrastructure environment too. Right? So parity is key to testing changes, being able to see something in a non-production environment for a change you're going to make. I'm going to upgrade a Kubernetes version. I'm going to add some additional subnets and see what happens, right? The one thing that's really hard with IAC is there are tools for testing IAC, but until that thing's in production, you don't really know that it works, right? Like just being able to Terraform plan and seeing that it says it's going to be okay doesn't mean it's actually going to make the resources, right? These aren't atomic commits like in a transactional database. It takes a while for DNS to propagate, right? And so to be able to have parity and be able to test things out in a very similar environment is the closest thing you can do to being just surefire prepared for production. Also, debugging configuration issues. Sometimes you might have maybe something that's bleeding a little bit of traffic and you don't want to go in and start toying with prod and your configurations. To be able to clone prod really quickly, change some configuration and try to figure out what's going on, also pretty key. And that's where parity can really shine. And also writing maintainable code. Like how does parity and maintainable code come together? So this right here in this image is kind of an old idea of how you should do things like Terraform. And it's still a very common pattern because it was so prevalent for such a long time. And it was this concept of having a different directory and different modules per environment. So here we just have production and staging, but you could have EU networks, production west, staging west. There is no parity here. When you have different bags of code that you're applying to these environments, you've lost parity. Your life is in chaos. You have no ability to tell what the difference is between staging and production because they have different sets of infrastructure being applied to them. Lots of stuff can go out of sync. You can't guarantee that parity, and nothing's declarative anymore. You have one big mental switch statements at the top, one big if statement. It's like, if staging, go apply these things. Hopefully somebody applies them all, right? So getting parity in your infrastructure is really important, and getting down to one module that can be applied to production and to staging is key in doing that. And there are two types of parity. When you, I'm missing a slide. Hold on a second. There we go. Two of my slides are backwards. There's two types of parity. There's architectural parity and there's scale. And so what I mean by architectural parity is having the same template that can be applied to all of your environments: staging, prod, US East, US West, preview environments. Architecture parity is about having the same resources. If I have Redis in production, I shouldn't try to cut costs by not having Redis in staging. I want to have a smaller Redis. I want to make sure that my application is able to connect to Redis, cache things in Redis, right? I want the same architecture, different scale. Similarly, if I'm using Postgres replicas in prod, I should have at least one replica in staging to actually test that my replication works, test that I'm actually able to access my readers. When you think about parity for scale, what is scale? It's CPUs, yeah. It's memory, it's disk, it's instance types, kind of. Some instance types, not so much, but it's also replicas. And this is one thing that's really important to think about. If you start to think about your replicas as scale and not as architecture, it really changes the way that you think about designing modules. And so going back to this example here, if we want to say, okay, well, this is this old model where we have a production directory and a staging directory, and we've started doing database replicas, you can see that I've got an extra directory of code here. There's no way for me to guarantee that we're going to have replicas and staging. I also can't enforce the order. What happens if somebody puts the replicas before the database or vice versa? Which order should they be in, right? Leaving that up to the person running this to have to think through it rather than the module handling it for them. We want our root modules between environments to have the same, or to be the same directories. We don't want separate directories here. As soon as you have different sets of modules between environments, you've lost hope of parity. Going back to the Postgres example, when we think about Postgres, we might want replicas in prod, right? We should have at least one in staging. We got to test protocol configurations, routing configurations, authorization, etc. If we have a Postgres module and a Postgres replica module, our developers can get into disparity between staging and prod pretty easily. If we go back to that leveraging locals example we saw earlier, what you'll see here is we treat our replicas as configuration of our Postgres module. You simply state how many you want as a minimum and how many you want as a maximum. This allows us to do pretty powerful things and codify a lot of stuff. As an operations team, maybe we say we always have a replica. There's always going to be one. Developers can set it to 2 or higher, or 1 or higher. Sorry, 1 or higher. There's always at least one there. Maybe we just let the developers set the maximum. Maybe we let them set the minimum and the maximum, and we configure some auto scaling to automatically scale up and down. But there's always at least one there, so we have that parity between our environments. You can see here, we literally treat our replicas as an integer. It's just a simple integer. We have the room. You can see at the end of this bottom line, we have the room to create additional configuration if and when people need it. But right now, replicas for our production Postgres databases is literally just a number. It's very easy to think through. It's very easy to capacity plan. So I have some slides out of order, so I'm going to go up a little bit here. Sorry, I'm going to flip around a bit. I don't know how these got out of order, but the other thing I want to talk about here is life cycles. So what is a life cycle? So it's a couple of things. It's when you create the resource, and a lot of these will be when you apply it. So it's your creates and updates, and it's when you delete it. And this last one's really important. A lot of people will refer to the term blast radiuses when they're talking about infrastructure as code. And I don't think that's a great term. It sums up the damage that somebody can do, but it's not the right mindset when you're thinking about how to design Terraform modules. What you should be thinking about is dependencies and the directed acyclic graph of those dependencies. What has to be applied first for your next module to be successful and be resilient in the face of disaster. And so we're going to kind of dig into that a bit here. let me get back to, sorry about this ordering thing, everyone. Get back to blast radiuses. So what about life cycles and dependencies? So it's important to think about when things go wrong when you're designing your infrastructure as code. We live in a blameless world, right? Everybody does blameless. So since it's blameless, I won't say any names, but I know a guy who deleted prod twice in one day. And he didn't do the accidental Ruby on Rails. They accidentally dropped the database or migrated. He fucking deprovisioned the production database twice from Terraform. Terraform destroy. Brought it back up. Terraform destroyed it again, twice in one day. Did we panic? Anybody know if we panicked? Goodness, no. We did not panic. We had backups. And this is really important to think about when you're thinking about life cycles. Where do your backups go? Breaking up modules by life cycle gives you a couple of things. It gives you smaller modules, which makes your deploys faster. It lowers the cognitive load. You're thinking about just this one very specific use case module. I don't have to think about backups and encryption and databases and replicas and scaling. I can just think about Postgres. Smaller commits for collaboration makes it easier to get work through, and safety. Being able to be resilient in the face of disaster. And so when you're thinking about lifecycle management, you have to think about what goes in this lifecycle. And so what I like to do is look at the main resource. So if we're going back to this AWS Aurora Postgres example, think about that main Postgres primary. And then you're going to ask yourself 2 questions for every single resource that's in that module. First question is, if I stop using the main thing, do I still need the auxiliary thing, right? So if I stop using Postgres, do I need Postgres replicas? No. If I stop using Postgres, do I need the Postgres IAM role? No. Great. Those things should go in a module together. They have the same life cycle. If one goes away, if the need for this goes away, I don't need the other thing. If I stop using Postgres, do I need the replicas? Databases are really funny. If I stop using Postgres, do I still need the encryption keys? Anybody know? If I stop using Postgres, but I still need Postgres's encryption keys. Yeah, I do. And the reason why is sometimes you stop using something in infrastructure as code because somebody accidentally deletes it twice in a day. And if your infrastructure as code keys, if your keys for your cloud are in the same bundle, your encryption keys are in the same bundle same module as your infrastructure, the keys are gone. If you have backups, you can't decrypt them. And so the second question, yes, you need the keys. Jacob and Amadeus, they're on it. You do need the keys. And so that's where the second question is. If disaster strikes, looking at that main resource, do I still need these auxiliary resources? So if I'm looking at my Postgres module and it's got my AWS backup vault in the same module as Postgres, if disaster strikes and that Terraform was torn down, I lost my backup vault. And so that's the second question I ask as I'm looking through a module is, okay, if something catastrophic happened to this infrastructure provisioning, what resources do I need to recover from that? Those are dependencies. I pull those out. I pull keys out. I pull backup vaults out. And I leave just the things in there that I know if Postgres went away, I definitely don't need these other things. They're not going to help me recover. Pop quiz. So given all the stuff that we've seen so far, can I take the exact same configuration, same names, 100% exact configuration, and apply it twice to the same account in a production workspace for Terraform and a staging workspace for Terraform? Anybody know? If I take the exact same configuration and apply it, change to production and apply it, literally same names, same everything, should it work? My answer is yeah, it should. My parity is in the inputs. My dependencies are inputs. I've codified all of my naming conventions. Copying a production configuration and just applying it to a fresh workspace, whether that's for like a regional migration, testing a major change, or debugging, and getting the exact same environment is really the key to getting good maintainable infrastructure as code. Again, it's not just about the code, it's about the environment that you have to manage on day 2. And if you can get to the point where when you're working on a module, you can take the exact same config and apply it to the same account twice, get two sets of resources that are in 100% parity with each other. You're in such a better place to start managing the infrastructure when things go wrong. And so this next kind of best practice is a little harder to do today, and we'll get into this in a little bit why, but having concrete inputs and outputs between your infrastructure modules. If we focus on using locals up front, we can start to think about designing the interfaces we want to expose to our module users. What should be a dependency? Make it an input variable. What does my team need to change? Make it an input variable. What's important for the consumers of this module to know? Make it an output variable. Each IAC tool has a way of sharing infrastructure. Terraform has this concept called outputs, and they can be accessed by this thing called remote state. So in this example here, this AWS example, there's 109 outputs. I can say, hey, my Kubernetes cluster has access to my remote state, and now I can read the networking information it needs. That's pretty cool. Let's one module read the state from the other. Remote state's terrifying. Like, this feels cool. It's great. It's flexible. I can do anything I want with that network. But if you want to give somebody one field, you give them all. It's terrifying. Anyone can do anything with this network. So if I give somebody the VPC output, they have access to all of the internals of my module, right? It really invalidates the, the robustness principle, right? Like, we're not being conservative in what we do whatsoever. We're just giving everything out, right? And what's really difficult about this is, robustness principle. It's kind of going back to that groupthink of like why modules are bad. 113 organizations behind this shared configuration have different ideas of what their team needs, and now your team has access to the same stuff, right? So you have this VPC that you're using for your transactional team or your backend team. Your MLOps team is using the same network. You want to share this network with your MLOps team who's doing MLOps. They're managing their own infrastructure. They've embraced DevOps. They have access to every single field in this VPC, all 109. So if you want to just give them some subnets and a CIDR range, they can see and access everything. Now, they could be putting things into subnets you didn't want them to. They could access passwords if this was RDS, right? Like, you're literally just kind of spilling the guts of your module into somebody else's infrastructure or somebody else's Terraform module. And what's scary is you can't remove these fields. I mean, you can, but it's a breaking change. You don't know who's using what field. So the output of Terraform modules and a lot of IC modules is this implicit contract. You're saying as the author, this is what I'm going to adhere to, but you have no idea who's using it. And you have no idea when somebody's going to remove that from the remote state, right? It doesn't break your infrastructure immediately. It breaks your infrastructure the next time you apply. So if my coworker, Chris, removes subnets from the output of this, and I run this module and maybe I don't have it pinned, all of a sudden it breaks. Why is my Terraform breaking? I didn't actually change anything. Oh, I didn't pin it and the field I was using got removed, right? So it's very easy to have these breaking changes kind of be introduced to this. And this is one of the things that MassDriver actually solves, and this isn't a hard sell here, but this is something I just wanted to talk about. But we actually have two tools here that we are going to be open sourcing the week after reInvent. So it's the week of, I think, the 4th. So if you're interested in learning about these tools, just drop a note in the comments and we'll follow up with you when we open source them. But effectively, there are two tools. One is a JSON schema interface for IAC tools. It works with Terraform, it works with Helm. It's going to be working with Pulumi shortly. And what this lets you do is it lets you define your interfaces and your outputs in JSON schema. So this gives you a explicit contract that you can share with your other teams that you can actually see in code and agree upon. It gives you rich validation of your inputs and outputs. You can actually do cross-referencing of fields. You can do conditional validation. And you can also use it for generating interfaces. We use it for generating the UIs in MassDriver. And we're also going to be open sourcing another tool called, that tool is called Airlock. And we'll be open sourcing another tool called Govna, which is an HTTP state server for Terraform, OpenTofu, and it's getting Pulumi support soon as well, that lets you essentially say specific fields that you want to share from your state file. So instead of sharing all the state, I can say, hey, you know what? I want people to have access to the subnets, or I specifically want the MLOps team to have access to these 3 subnets. And now when they pull the remote state, they get a filtered view of that remote state. and you have this contract in between the two teams kind of enforcing. So these are some of the things that we're going to be open sourcing soon, but this is something that you can do today when you're doing your IAC and just thinking about like what is really important for this downstream consumer to know. They don't need to know everything about the insides of my module, and I don't need to expose everything to somebody who wants to use this module. Okie doke, so we're at 10:45. So as far as module management goes, this one's kind of a goes back to that blast radius idea. We want to avoid big modules. You don't want to have really big modules. You don't want a module that deploys your entire cloud infrastructure, right? A couple of things happen there. One, it's just very hard to maintain. It's hard to do pull requests. The blast radius gets scary. If something goes wrong, there's a lot of resources that are in there, but it also just takes longer. So if I have 200 resources in my module, Terraform has to read every single one of those before I make a single small change, right? So having 2 or 3 or 4 or 5 or 6 modules that are much smaller allows you to apply things more atomically and get faster rollouts because you're not essentially reading things from the cloud that haven't changed. Functional declarative infrastructure, like by having these inputs and outputs, inputs into this module, create the module, has outputs that feed into the next module, give you a nice streamlined pipeline approach. And a lot of the IAC tools today are starting to roll out. IAC tools and the taco companies, Spacelift and Zero, et cetera, are starting to roll out these concepts called stacks that let you roll out a series of modules together. And that is how I've been doing IAC for a very long time. I used to just do it with make files, but it allows you to have very small atomic commits. And so that's a very, very powerful tool. And you'll be able to use airlock and Govna to help with that if you're interested. So that is in a nutshell. So like kind of thinking back to that Postgres instance, right? So it's like, I want to create a key for KMS. I want to feed that key as an input into the thing that makes my backups. And then I want to feed my backups and my key as a dependency to my Postgres instance. That gives me the ability to share a key for encrypting my Postgres, share the same key for doing maybe my backup vault, but be able to A, lower the interface for my users, and B, be resilient in the face of disaster. If that Postgres instance gets destroyed off the face of the planet, it doesn't take its backups and its keys with it. So what I want to do is just give a very, very quick demo of MassDriver and then open up for conversations and questions. So let me just pop this link open really quick. So what our platform is effectively a visual tool for managing infrastructure as code. And you can see here, I've got what we call bundles on my canvas. And so what's happening here is here's a VPC, here's Postgres, here's my applications, and here's my cluster. And you can see kind of a lot of these concepts coming into play here. These lines between are the inputs and outputs mapping together. It's me taking the dependencies of one and mapping it into the other. And what you'll see if you look at these, what we call artifacts, is they're very, very tight, constrained, explicit contracts between different components. So this VPC output isn't all the guts of my VPC module. It is very specific fields that is important for the rest of my modules to know about. And in MassDriver, these are actually real typed interfaces. So we do strict typing between these things. So on this side, I'm saying that Postgres needs a VPC. This allows us to do a lot of cool things, like if you say you need an S3 bucket, we can auto-generate some of your infrastructure. But we take care of not only storing your Terraform, very similar to the Terraform registry, but we also handle the provisioning of that infrastructure. So you can see here, this is that airlock tool, JSON schema tool, generating an interface. This is the 1, 2, 3, 4, 5, 5.5 fields that we ask for on our VPC. You can uncheck this and you can fine tune and control it. So trying to give our developers or developer users a very constrained interface with the ability to extend as necessary, and they can always fork and add more fields if they need to. So here I'm just gonna hopefully not run out of elastic IPs, hit deploy. We also take care of all the provision of your infrastructure and CD for your applications. So we'll actually provision your Terraform, we'll do all of your state storage. We do things like automating AAC, principle of least privilege for IAM, the IAC. And we also have just a ton of infrastructure components that are already in here. You can also publish your own. You see all of our infrastructure components we ship with SOC 2, HIPAA, NIST, CIS, et cetera. So if you are in the world of Terraform and you're starting to build Terraform and you want to be able to expose it to your developers so they can, act faster, deploy things without constantly bugging you or getting pull request reviews. Master is a great opportunity. You can publish your modules in there, let your developers just drag and drop what they need. We keep version control of everything, deployments, every single change that's there. You can diff it visually over time. We have an audit log of every single change. So check it out if you got time. And we got 9 more minutes. So happy to answer any questions on Terraform, IAC, Kubernetes, anything in the cloud space. Does anybody have any questions? How do I start with a blank slate and write good modules like the RDS Postgres keys? Is reading the docs enough? I would start very small. So yeah, there we go. Very cool. Sorry, I just saw it pop up on my other screen. I start very small. Whenever I'm working on a new service, and I work on a lot of services that are new. And the reality is like, you're going to do a ton of reading as you work through it, especially as you get around like alarms. So AWS is very good for each one of their services on having pretty rich documentation on best practices for how to configure it, when you need KMS keys for different scenarios, what alarms they think you should be watching. And so I do a ton of reading, but I literally just start with that base resource. And I do one resource at a time and kind of slowly work my way through it as I'm reading the docs. And even for services that I'm very familiar with, I've been working with Postgres for 10 years. I will still read the docs because stuff's always changing. You're always getting new features. So I think blank slate's a very good place to start. Another thing is like the one value in the Terraform registry modules is people have grouped the resources together. Like that's the real value I see in them. So while there's not a lot of locals and logic in there, they get you the value of taking that dependency. I'll frequently reference them and then just kind of grep the word resource to see like, what are all the base resources that I should be including in my module? Great, I'll put those same modules, but now I start hard coding values that I don't want people to change. I start with locals to do some computations for things that people shouldn't have to worry about. Any other questions? Follow-up question, how do I test the module correctly? Yeah, this is the hard one. So this is very, very hard. So Terraform 1.6 and OpenTofu both have a test subcommand that lets you write tests in HCL. I think it's miserable. Writing tests in HCL is not a good experience. There's another tool called TerraTest by the TerraGrunt team, and it's a much better tool, but I think it's all in Go. And then if you look at, so there's TerraTest, and then if you look at Google Cloud has a team called the Cloud Foundation Toolkit. And if you go look at Google Cloud's Cloud Foundation Toolkit, very similar to a lot of the Terraform registry modules. Like there's some of them that are pretty thin. There's some in the Cloud Foundation Toolkit that are really good though. Like the project managing one is very, very good. If you go through those, you'll see that they use a tool called Kitchen, which is a derivative of Ruby's RSpec. So you can use TerraTest and write Go. You can use Kitchen and write Ruby. But effectively, what both of those tools do is they will apply the Terraform. So you'll want to, maybe you have your production config and you just want to apply it to a test environment. You have the exact same config, and then it's kind of like an imperative test. But you have to do a lot of the work yourself. So you have to think about like what that use case is, and that makes the testing much easier, right? When you're trying to test something with 220 inputs, that's a lot of tests. But when you're trying to test a network that has 5 inputs, like there's not a lot there to change and test, right? So it's much easier to think about doing like kind of test-driven development with the infrastructure. So those are the 2 tools. But like effectively, it's like if you're making, let's say, a Postgres, it's like you have to, and you want to test that like it requires SSL auth, right? Effectively, you can test that the field was set, sure, but to actually test that it really requires SSL and that you can connect to it, you have to place a Bastion node that your Go or Ruby code is able to SSH into, and then use a pSQL client to try to connect with SSL. So testing infrastructure is very hard to do in an automated fashion, but those are probably the 2 best tools out there. Quite happy with AWS CDK for now. When or if do you think we should switch? If it's working for you, use it. I mean, that's great. I wouldn't switch for the hell of switching. Now, where the cost comes in, like AWS CDK is very cool. But what I'm usually thinking about, and my scenario is very different because we have customers in all three clouds, but I tend to think of tools like Pulumi or Terraform as my go-to because they allow me to have the same tool that works across all three clouds, right? So if you're definitely going to be in AWS for the long run, like you don't need to switch. But if you're getting to the point where you're going to start managing, let's say, an OpenAI instance in Azure, right? Now you're taking on another tool. You either have to go learn, Azure has their own IAC tool called Bicep. You either have to go learn Bicep or you have to learn Terraform. And now you have two pipelines for managing infrastructure. You have your AWS CDK, you have your Terraform, right? And so like that's when I start to think about changing, is when I have some significant need, or when you think you should think about changes, when you have some significant need to start deploying infrastructure in another cloud, right? And so I think that even in that scenario, it would have to be significant, like outweigh the costs of migrating, right? So if you have like a single OpenAI instance in Azure, maybe ClickOps is fine for managing that, and use AWS CDK for managing your clusters and your databases and your networks and everything else in AWS. I think that's a fine approach. But if you start getting to the point where it's like, okay, we got a cluster over in Azure and we got some blob storage, and now we're starting to do a lot of Bicep or a lot of Terraform to manage it, like that's when I start looking towards a tool like Terraform or Pulumi that can have just one tool chain for CI/CD, one tool chain for doing compliance and analyzing policies, and I don't have to think about two different CI/CD flows or tools. Very good question. Very cool. Anything else? Okie doke. Any other questions on LinkedIn or Twitter or Twitch? I don't see any elsewhere. Awesome. Well, if there's no other questions, thanks so much for the time. We'll be putting this on YouTube so we can share it with you if you want to rewatch it. And as I mentioned, if you are interested in checking out some of these tools that we're going to be releasing for the IAC ecosystem, Airlock, which is a validation and interface tool for modules, works for a number of different IAC tools, or Govna, which is an HTTP server for Terraform State. Just drop a note in here and we'll make sure to update you when those go public. Awesome. Thanks, Jacob. Thanks, Amadeus. I really appreciate the questions. Awesome. Have a great day all.